over 15.7 billion miles, humanity's most distant ambassador has been flying into an abyss of unimaginable darkness. Voyager 1 is currently tearing through the interstellar medium at an astonishing speed of 38,000 miles per hour. Built with technology from the 1970s, the entire working memory of the computer running this spacecraft is exactly 69.63 kilobytes. That is less memory than a single low-resolution thumbnail image on your phone. The mission was originally designed to last a mere 5 years. But the terrifying reality of what Voyager has encountered at the very edges of our solar system, and the desperate, high-stakes medical triage engineers are performing via radio waves to keep it alive today, sounds like a science fiction thriller. When Voyager 1 and its twin, Voyager 2, launched in the late summer of 1977, they were taking advantage of a rare planetary alignment that only occurs once every 175 years. Their objective was a grand tour of the outer gas giants. Voyager 1 performed flawlessly, returning images of violent active volcanoes on Jupiter's moon Io and threading the needle through the complex rings of Saturn. But at Saturn, Mission Control faced a brutal choice: to get a close look at Saturn's largest moon, Titan, and its dense, hazy atmosphere. Voyager 1 had to be steered onto a trajectory that would fling it below Saturn's south pole and permanently out of the plane of the solar system. The Titan flyby was a success, but the cost was absolute. The maneuver guaranteed that Voyager 1 would never visit another planet again. It was essentially a one-way ticket into the cosmic void. But the true darkness of this journey didn't set in until years later, when NASA made the chilling decision to deliberately blind the spacecraft. On February 14, 1990, Carl Sagan convinced the agency to turn Voyager 1's cameras around for one last look at home. From 3.7 billion miles away, it captured the pale blue dot, Earth, reduced to a fraction of a pixel, suspended in a sunbeam. Just 34 minutes after the shutter closed on that iconic photo, Voyager's cameras were powered off permanently. The software controlling them was deleted to free up computer space and conserve energy. For the last 3 decades, Voyager 1 has been flying through deep space completely blind. For a long time, we assumed the space between the stars was empty and calm. Voyager proved us dead wrong. In August 2012, Voyager 1 became the first human-made object to cross the heliopause, the magnetic boundary, where the protective solar wind of our sun is violently abruptly stopped by the pressure of the interstellar medium. When it breached this invisible wall, the spacecraft's plasma wave subsystem suddenly detected extreme oscillations. The probe had plunged into a chaotic environment where the plasma density is up to 80 times higher than inside our solar system. Out there, the sun's protective magnetic bubble is gone, and the tiny spacecraft is constantly bombarded by high-energy cosmic rays originating from explosive supernovae across the Milky Way. But while Voyager battles the harsh environment of interstellar space on the outside, its most terrifying enemy is decaying within. Voyager doesn't run on solar panels. The sun is nothing but a bright star in its sky. Instead, it relies on radioisotope thermoelectric generators, which convert the heat from decaying chunks of plutonium-238 into electricity. But plutonium decays. Because of this, the spacecraft is bleeding power, losing about 4 watts of electrical capacity every single year. To stop the spacecraft from freezing to death, NASA engineers have been performing extreme palliative care. For decades, they have been executing a slow, calculated triage, systematically killing off heaters and science instruments one by one, so the core of the ship can survive. The fragility of the mission became terrifyingly clear in November 2023. A single memory chip failed inside the flight data subsystem, and suddenly, the most distant object humanity ever created started transmitting a continuous, meaningless stream of gibberish. It took engineers 5 agonizing months of digital archaeology to rewrite the 1970s code, break it into fragments, and hide those fragments in empty corners of the remaining 69 kilobyte memory. They were fixing a computer 15 billion miles away, where a single keystroke takes 22.5 hours to reach the craft, and another 22.5 hours for the reply to come back to Earth. The crisis struck again recently. In late February 2026, the spacecraft experienced an unexpected drop in power during a routine roll maneuver. If the voltage dropped any lower, an automated failsafe would trigger, blindly shutting down critical systems and risking the complete loss of the spacecraft. NASA had to act immediately. On April 17, 2026, engineers sent the command to permanently kill the low-energy charged particles experiment, an instrument that had been running almost without interruption for nearly 49 years. NASA is now preparing a massive, highly dangerous last resort fix known internally as the Big Bang. The plan involves simultaneously shutting down a group of older, power-hungry components and swapping them for low-power alternatives in one fell swoop, just to keep the spacecraft warm enough to transmit data into the 2030s. When that final reserve of power runs out, the transmitters will die, and the spacecraft will plunge into total silence. But its journey will not end. Bolted to the side of Voyager, one is a 12-inch gold-plated copper phonograph record. It contains 115 images, the sounds of wind and rain, greetings in 55 languages, and the compressed audio-encoded brainwaves of a young woman thinking about what it means to fall in love. In about 40,000 years, long after its radioactive heart goes cold, this dead metal ghost ship will drift within 1.6 light years of a star called Gliese 445. It won't call home. It won't take pictures. It will simply sail onward through the endless dark, carrying the ultimate memory of a species that once looked up at the night sky and refused to be forgotten.